We're going to talk about coordinates and plotting points. So here is your typical coordinate system where you have a vertical axis and a horizontal axis, and notice that these are lines, so they extend into infinity. I've stopped at -6, but they actually go on to infinity. And in the middle of that, where the two lines cross, you have what's called the origin, or the 0, 0 point. When you have a coordinate plane, the vertical line is always the y-axis. The horizontal line is always the x-axis. When you're given a point, for example, 3, 2, points are always going to be written like this, where they're going to be in parentheses, and then you're going to have two numbers separated by a comma. The first number is always your x coordinate. The second number is always the y coordinate. So you have your x and your y. So when you're plotting a point such as 3, 2, you always start at the origin, at the 0, 0 point, and you go for your x coordinate, you go that many over. Now, if it's positive, you're going to go to the right. If this is negative, you're going to go to the left. So we're going to start at 0 and go over 3. 1, 2, 3. And then from that point, you're going to look at your y component. So here, it's a positive 2. If it's positive, you're going to go up. If it's negative, you're going to go down. So since it's a positive 2, we're going to go up 2. 1, 2. So the point 3, 2, you would plot right here. If we have a point, for example, -4, 3, again, you have your x component and your y component. So x is -4, so you start at the origin. Since it's negative, we're going to go to the left. 1, 2, 3, 4. And then from there, your y component is a positive 3, so we're going to go up 3. 1, 2, 3. So that point would be plotted right here. We'll do one more. If you have -3, -5. So here we're going to go -3 on the x, 1, 2, 3, and since y is negative, we're going to go down 5. 1, 2, 3, 4, 5. So it's going to be right here. -3, -5. So that's how you plot points. It's always the first number is your x, which way you're going to go, left or right. Your second number is your y. Are you going to go up or down? One other way that you'll be tested about coordinates sometimes is when you're talking about lines, and they'll ask you what the y-intercept is. So for example, if we have a line, let's say like this, the y-intercept means where does that line cross your y-axis. And again, your y-axis is the vertical line. So here you can see where these two lines intersect, or where this line crosses the y-axis, is right here. And so what is the coordinate of that point? Well, since when you start at the origin, we're not going either way, left or right, so your x component is going to be 0. And then y, 1, 2, 3, 4, 5, is your y component. So this point is 0, 5. That would be your y-intercept. One other way that they might test you on graphing and plotting is they may give you some points, for example, for a square or a parallelogram, and they'll ask you to find the last point. So let's say they give you parallelogram. They give you a parallelogram, and they give you 3 points. -3, -2, -1, 2, and 3, 2. So the first thing you need to know how to do is to plot these points. So -3, -2, start at the origin, 1, 2, 3, down 2. So that's right here. -1, -1, +2. So -1, 1, 2, positive 2 is up here. 3, 2, 1, 2, 3, 1, 2 is up here. And when you connect these, you can see you have two sides of a parallelogram, and they're asking you, where's that fourth point? So we know that it's going to be down here somewhere. We know because these lines are parallel on the top and the bottom, since this is at -2, that it's going to be along the -2 line, so we know our y component is going to be -2. The relationship on parallelograms is that the relationship of this point to this point has to be the same as the relationship of that point to whatever our missing point is. So to get from here to here, we went down 1, 2, 3, 4, and then we went over 3. Over 2. 1, 2. So we went 1, 2, 3, 4, 1, 2. We went down 4, to the left 2. So we're going to do that the same here. 1, 2, 3, 4, and then to the left 2. 1, 2. Which is going to put us at 1, -2. And when you connect them, if it was drawn more precisely, you could see that it's a parallelogram.